Hello and welcome back to quicktechie.com. In this session, we are going to discuss about Apache Spark remaining concept. So let me go there. So this is the place where we left. So now let me discuss about the resilient distributed data set RDD. RDD is a concept you must learn if you want to work on Spark. However, it is highly recommended while writing program. You should avoid using RDD until and unless if you really want to use, because RDD, if you use directly, it bypasses all the optimization technique which Spark has introduced from Spark 2.0 onwards, like it Catalyst Optimizer, Project Tungsten, etc. So a lot of optimization was done. If you directly use RDD, it would bypass this optimization and would impact the performance. So you should avoid writing code using RDD if you are writing a new program. Correct? But you need to understand the RDD concept in detail, how this works if you are working on Apache Spark. So let's assume it this is your 4 node cluster of Spark, correct? And one node crashed. So what would happen with your RDD? So why this RDD is called resilient in a resilient distributed data set? Because this is your data set. If you do first calculation, it would generate a one RDD. Then this on this RDD, it performs some calculation, it create another RDD, and then it perform another RDD, and this is resulted RDD. Now, if this RDD crashed, this machine is crashed as shown in image, which holding this RDD, then what Spark know? Basically, this entire graph Spark knows when it basically it requires to regenerate that RDD which is crashed. So that is where the it is called resilient. So you don't have to worry about this if node crashes. So it automatically failed over, uh, or basically you can say it will be generated again from on the new node if it is required. So in Spark internally redo all this on another machine because this machine is crashed. So Spark will perform, let's say selected this machine, and it would perform this and prepare this RDD again. So that is where it is called the resilient. So you don't have to worry about this, how this RDD would be regenerated if machine crashed or anything. So that is Spark responsibility. Now moving to the distributed. What does here distributed? It is very easy to understand because now we are on distributed programming. So basically, but let me explain here. Suppose this is the file which has a 1000 lines you see here. So what Spark does basically on 4 node cluster, let's say we divide this into 4 partitions. So this file is divided in 4 partitions, and each partition has a 250 lines, as you can see correct here, and these 250 lines are created as an RDD and set to send to different machines. So partition P1 stay here, partition P2 stay here, like this. So this way, so this is distributed. Your 1000 line distributed across 4 nodes. Each node is having 250 lines. Each can run parallelly. Some processing on 250 line here, 250 line processing does here, some processing is done here, same processing is done here. So it happens parallel on 4 machines, so which makes your overall calculation much faster. So data is distributed on 4 machines called 4 partitions, and framework can work parallelly on each node on a different partition. So that is where this is distributed. So this is resilient and this is distributed. And data set, obviously this is a collection of data, so this is called data set. Now, important things to remember is RDD is immutable. What does it mean immutable? Immutable in means in English means the things which you cannot modify your own. So once RDD is created, you cannot modify it. So then how system works? Basically, you need to create a new RDD from existing RDD if you want to do some modification. So for this example, this is your input data set. It creates an RDD1. Now if you perform some calculation on that, so this itself would not be modified, rather it would create a new RDD with a modified data, or which is whatever calculation you want to apply on this, it would generate new RDD, that is called RDD2 or whatever basically. And again you apply some calculation, it will need to generate new RDD, RDD3 and RDD4, something like that. It would continuously generate, but it would not modify any existing RDD. It would create a new RDD to and not modify your existing RDD. And once you perform action, it would finally generate the resultant RDD. So again, new RDD. So RDD can be cached to memory. So like caching is heavily used in Spark. RDD can be serialized and saved to disk. So like that can be generated. So what does it mean here? Suppose this is one RDD, correct here. HadoopExam.com is a value in that RDD or that string you have. I can't modify this RDD itself. What I need to do when I do the transformation on this RDD, I can create a new RDD. I cannot modify this RDD. I has to create a new RDD if I wanted to generate uppercase or convert this entire string to uppercase like this. So then new RDD is created. So this is one existing RDD and new RDD would be created. So keep in mind, you cannot modify existing RDD. You can create a new RDD from existing RDD. So that is what is a using transformation or action, whatever you do. So this is the simple Java code how you do this. So that is very important concept. RDDs are immutable. You must remember that. Main advantage of Spark, you can develop big data application on your personal computer. Basically, while development, you just write a code on your single computer using high level API, and you just need to focus on your business logic, and you can deploy in a big cluster once you are ready, your application is ready kind of thing. So you can test it, you can develop it, and everything you can do on your laptop with a single machine. So that is the main advantage. So it is easy to use. Spark is fast and high performance computation engine for big data and analytics world. As we have discussed already, this is in some scenario 100 times faster than MapReduce. Correct? Not every scenario, but many scenario it can be faster than. General purpose computing engine, as we discussed, you don't need so many framework like to do or engine to perform different kind of calculation. Like if you wanted to run SQL queries, you can use Spark. If you want to run text processing, you can Spark. If you wanted to do graph processing, you can Spark. If you wanted to do machine learning, you can do this. Stream data processing, you can do this. And this is general purpose engine as well as you don't have to learn different programming languages. If you know SQL, you can use Spark. If you know Java, you can use Spark. If you know Scala, you can use it. If you know Python, you can use it. Correct? So that's way, and even for our language. So you don't need to learn new languages for using Spark framework. Any language which you know, you can start working with Spark. Correct? But however, the most popular is a Scala, Python, and SQL among all. If I wanted to prioritize, so basically Scala and Python on same level that are extensively used. Then second is SQL. Third is R language and Java language. That is the order is the people are basically considering Spark. Previously, you usually need to do use different engines for different activity as we have discussed. Correct? For SQL queries, you use Impala or Hive in Hadoop. Text processing, you write MapReduce. Graph processing, you need different framework. Machine learning, you need Mahout, and stream processing, you need Storm or something else. Correct? So different framework you need to create, you need to learn kind of thing. So a lot of learning curve is involved with the Hadoop MapReduce and Hadoop framework. But Spark is not the case. Business use cases of Spark is like data scientists can use Spark, business intelligence purpose can be used, data engineer can use for ETL activity, they can use the Spark. Processing in parallel large data sets distributed across the cluster, correct? So you can process large volume of data. Perform ad hoc or interactive queries to explore and visualize the data. Well, when we'll do the hands-on, so we'll get to know all this detail, like basically, correct? It may be possible you may have to revisit this session to understand more if you're if you're learning first time the Spark framework, and implementing end-to-end data pipelines from myriad stream of data, that is different pipelines you can create, analyze graph data set and social networks. That's what you can do. So Spark is very good general purpose engine which support different programming. So this is just in a map reduce we have already discussed, so I'll not go through this, simply quickly. So this is you read from ftfs data, read it, then splitting, mapping, shuffling, reducing, and write back to the htfs. Then again you need to do calculation, you would go through the same process, and then finally write your query to generate the result. So just pictorially, I wanted to show you. So I added this diagram over here. Hadoop framework involves your MapReduce, cluster manager, it's a scalable, optimized storage, various file format will work, even various file format with the Spark, correct? So that is Arrow, Parkway, Sequence, ORC, and we'll discuss what is the use and benefit of use. Correct? Fault tolerant, Hive engine, Uzi workflow, big Flume scope. Who are the leaders in this Cloudera? AWS, EMR, Google Cloud, IBM, Azure. So these are the leader in this world basically. But in Spark, you would use cluster manager from Hadoop as well. Various file format you will work in the Spark as well, correct? Storage of HDFS you would be using with the Spark. So lot of things from the Spark also you are going to use it. Uzi workflow can basically trigger your Spark pipeline as well. So that is where Hive engine you can connect your Spark to Hive as well. So that way, so many things are being reused from the Hadoop framework in the Spark world as well. So that is where it is. So that's all about this session. Thanks for watching, and I hope you like this session. If you are watching on YouTube, don't forget to subscribe it and keep visiting hadoopexam.com and quicktechie.com. So both have come together to create a new session with the more hands-on. Thank you. I'm stopping now. Wish you all the best.